What's up? Another month, another project video. I'm just going to start off by running the unit tests over on the terminal. Fortunately, they will succeed after we get test 5 running over here. Awesome. So now we can just compare the heap management strategies. I'm going to start by just looking at the output for these tests. So for the first couple, you can notice that it doesn't really matter. The results are the same for all 3 heap management strategies. For the third one, we see that there is a difference. We see that the heap size is minimized by the best fit strategy. We see that the fragmentation here is best for the best fit strategy as well, although that kind of changes. And then for the time, we can bring the console back up, and we can see in test 5, the first fit is definitely going to be the fastest, which makes sense because it doesn't have to make decisions. It just finds a free block. We look at 4, we get pretty similar results to what we were seeing earlier. We can also open up the console here and test the commands manually. So if we do that, we start to see something interesting. If we just test the best fit, so look at the internal fragmentation there. Now if we test the worst fit, we actually see that it's much less. And I think this kind of makes sense because if you use best fit, you're not going to be able to split your blocks as often. So you're going to get a lot more gaps, a lot more internal fragments between the size and the capacity of the block. Whereas for the worst fit, you can typically just split the block and get those perfectly sized blocks that you want. Now, on the other hand, for external fragmentation, I think it's not the greatest because if you're splitting blocks all the time, like you will be for worst fit, you're eventually going to end up with a lot of blocks that are actually too small to reasonably use. And so those are going to fall by the waysides. And I think you can see in our comparison that the external fragmentation for the worst fit has been pretty consistently high. So I don't think that there were many errors or odd behaviors in this project. There was a lot of struggle to get to the point where there weren't the errors. One thing I've been wondering in this project is whether I coded more lines of code or wrote more print statements to test the code. I also followed your advice extensively of drawing drawings. This is just one page. There's a few of those. It was pretty effective, except when I just drew the wrong drawing, but we redrew it and got there. I learned a lot about heap allocation in this project, basically just deep diving into manually moving the heap, allocating memory, using data structures like the circularly double-linked list to represent the free list of available blocks. Basically, I actually know what's going on when I run Malloc now. It's not just magic. Does this mean that I'll be able to use Malloc without encountering errors in the future? Definitely not.